We are going to be working on pure algebra again, and we're going to be looking at, this is homework 19, just should have put that in. We're going to look at a technique called completing the square. This technique is going to allow us to solve equations that you can't factor. Right? Because if you remember what we did last Monday, is we factored the thing, and then from those two factors you would get two solutions. And that was good because it brought back a whole load of things that we had done before and just used them in a different way. But this fella, completing the square, I can't spell completing, so let me do it again. There we go. Has anybody ever heard that term? It may be totally new to everyone. Okay. Let's jump right in and show you what completing the square looks like. Let's take an expression like x squared plus 8x. When they say completing the square, what they want to do is they want to take this thing and we want to turn it into an expression squared. The correct answer for this one is x plus 4 squared. Now, it's not that these are equal to each other. That's probably not the best way of saying it, but it's more like we're turning it into this thing. And this process is called completing the square. So you take an expression, whatever it might be, and you rewrite it, you convert it into another expression that is basically the same guy times itself. That seems like, why would you want to do that process? Well, once we're good at completing the square, what we can then do is we can use that to solve equations that don't factor well. That's essentially what it's for. So, totally algebraic and totally magic, what I'm now about to do. I'm going to show you how this conversion works. And put little arrows in. Half the number of x's. So if I take this guy here and I half the number of x's, and you got all that, then square it. So half the number of x's, and you square it. So do you see that? Now, do you notice what happened to the x? You get that. And this is the completed square. That's pretty much the process. So let's try another one. Suppose it was y squared plus 10y. And I'd like to complete the square. Right. The y squared gets you y. What do I get from the 10y then?
5.
And we have now completed the square. Wasn't too bad. Can
What
do it
is
with negative.
Oh, sorry. In the quotations, like, and then it says then square. Does that say then square it?
Yes, it does.
Okay.
And all I mean is that you put bracket around the whole thing and square it. So I'm really talking about that little piece there, that tiny little 2. So half the number of y's and then square it. Right? Half the number of y's, that's the 5, and then square it. Can do it with negatives. If I wanted to complete the square for z squared take away 8z, what would I get? I get a z. What do I get here?
-4.
Minus 4. And then remember to square it.
Square.
Yeah. Now, I'm not saying that this is equal to that. What I'm saying is I've converted this thing into a new thing called completing the square. I haven't done anything else except that. That's all I've done right now. Later on, we're going to do some other stuff to this completing the square so that the things are the same, are equal to each other. Are we good so far? So if I gave you something like that, would you feel comfortable about completing the square? So let me jump right into the homework and show you what it looks like in the homework, because this is really just the intro to this process. Oh, let's not have the key. That would be kind of defeating the purpose. Okay. So I'm forever this homework. Here we go. Almost done. Right. So this one, you would go x take away 4 squared. And this one, x plus 4 squared. This one, x take away 4 squared. Ah. No. Right, that's it.
So where it says write the resulting trinomial as the square of a binomial, what would that be?
That's a very good question. Sign up. Oh, I know what it is. The answer I gave should have went there. They've done this, the next bit in one question. So I guess I should show you the next bit.
When I put the answers in for that one, for the number 1, it took what you said, like the in the parentheses x4 squared. It took that for the first box.
Oh, so it did take that. Okay.
I'm just confused on what to put on the second box.
Right, I'm a little bit as well, but it's just whatever sign. I know what it's going to do, but I may have told you the answer that goes into the second box, not the answer that goes into the first one. But I'm about to show you the second piece of this, and that will make it all come out. If since I'm running short of room, if I take this question again and I talk about completing the square, what I'm talking about is making it now into a perfect, the whole thing, right? So what would I need to do to this guy to make it become the whole thing, right? To make it equal to each other? Well, the rule is half the number of x's then square it, and the last piece is then subtract. So let's see what this last piece of the puzzle called and then subtract is. So I'm going to take half the number of x's and square it. Now the bit I'm calling subtract is, see that half the number of x's, which is 4? If you square it and subtract, you get 16. Now what that is, okay, excuse me, I've just figured out what the heck they are doing here. This is the correct answer for what I am doing. If you take this expression and you multiply it out, and then you subtract 16, you will get x squared plus say x, and I'll prove it to you by foiling. There's x squared. There's your 4x. There's your 4x. And there's your 16. And then if you subtract the 16, do you see that you get left with the original? So what you're going to do is you're going to halve the number of x's, square it, and then subtract. I'll put it in English. Half the number of x's, square it, then subtract. Okay. Try another one. Suppose you were wanting to do y plus 6y. You want to complete it square. Half the number of y's, square 3 is 9, right? So half the number of y's, square it, and then subtract. Now notice that the number that you subtract is also the square. So 3 squared gets you 9. How about z squared plus 10z? Okay, let's complete the square on this one. Half the number of z's. What do I get? What do I do now? Well, I've got that 5. What do I do with that 5? Square it and subtract. I know it's total magic, but are you seeing this process? It's really just a process. Half the number of, in this case, z's or y's or x's, square it and subtract. Try this fella. Okay, let's compare the, complete the square. Do the first half. What goes inside the brackets when you start with this fella?
X minus 2.
Okay. What do you subtract? So x minus 2, let's square it and subtract. Now be careful, what number do you get if you square negative 2?
Positive 4.
And now you subtract it. If you FOIL this out, you will get back to that. This is completing the square. This is the full part of completing the square from start to finish. Now, I haven't tried to explain even vaguely why this works. You just have to kind of trust me, right? You have the number of x's, negative 2. You square that negative 2, 4, and you subtract it. What would w add? Well, I'm not sure the numbers I've not done. 12 squared. What would w squared plus 12w? That's what I meant to do. Now let's try this one. W squared plus 12w. What goes inside the brackets here?
W plus 6 squared minus 6.
Minus what? Not 6.
36.
Yeah.
Yeah.
Remember that little square, right? Square it and subtract. Okay. What goes in box 1 and box 2? I'll look at the solutions, but I'm pretty sure one of these things is box 1 and the other thing is box 2. That's really only happening in the first 2 questions. After that, they start doing it the way I'm doing it. Okay. Now, I think I should do a couple for you to try. Although there's not too many numbers I can do it to. So there's one. Okay, give you a minute. Complete the square on these 2 things. Okay, let's go. What's the answer to x squared plus 6x? What will we get from it? X squared plus 6x. What goes in the brackets and what do I subtract?
X plus 3 squared minus 9.
And for the second one, y, complete it now. What would you get
Minus
here?
5 square minus 25.
Okay, it's total magic, but are you comfortable about how to do the magic? If I gave you, x squared minus 20x or something, you'd feel comfortable about this completing the square process, right? No, it's not obvious why you would want to do that yet, because I haven't shown you. And it's not maybe even clear why it works, but it does work. And if you don't trust me, FOIL that out and you'll eventually get this. FOIL this all out and collect like terms and you'll eventually get this. So it does work. So the reason we're doing it is so that we can solve equations that don't factor. So I'm going to show you. A quadratic equation that looks a bit strange, but it's going to help us because a lot of our later questions are going to end up looking like this one. Right, I have x minus 4 squared, take away 9 equals 16, right? And I would like to solve for x, right? I'd like to solve this equation. Now we're going to use a technique that we've used many times before. As long as you do it to both sides, it's okay rule. Now, before completing the square happened, we would probably FOIL this out and do all sorts of stuff, but we're not going to do it this way. What I'm going to do is I'm going to add 9 to both sides. Right, as long as you do it to both sides, it's okay, right? If you add 9, see how this disappears? Now, what do you think I should do to both sides to get closer to finding x? This guy squared is 25. What do you think I should do to both sides to get closer to finding x?
Square.
Yes, square root. If I was going to say, if I cover that up, isn't it just something squared is 25? So I'll take the square root of both sides. Now, if you take the square root of this guy, you get x minus 4. What do you get if you take the square root of 25? What
5.
number? Say again, Vanessa.
5.
Yeah. Do you get any other version of 5? Is it just 5 or do you get another version of 5?
Oh, is it plus or minus 5?
Yes. So what you get is x minus 4 squared plus or minus 5. And all I've done now is separate it out into two separate things, right? I've got an x minus 4 equals negative 5. Shouldn't be a square there. And an x minus 4 equals plus 5. Now, if I add 4 to both sides, I get negative 1, and there's one of my solutions. And if I add 4 to both sides, I get my second solution. Do you see I've now managed to solve this equation?
Wait, I forgot how you got x minus 4 squared away to make it the plus minus 5.
What I did to get from here to here is I take the square root of both sides. Now, if you take the square root of something that's squared, you just get the thing x minus 4. And if you take the square root of a number, remember you get a plus and a minus. So you get a plus or minus 25. So the square root of that guy is 5, plus or minus 5. Suppose I have x plus 3 squared minus, say, 10. And this time the answer is 2. And I would like to solve that equation. Then I'll add 2 to both sides. I'll then take the square root of both sides, and that will give me plus or minus, in this case, the square root of 12. And then when you get to this stage, it's helpful to split it into 2 distinct situations. The x plus 3 is negative root 12, and the x plus 3 is positive root 12. And subtract 3 from both sides. And then subtract 3 from both sides. These are the solutions to that equation. It's a really weird one, but it is the solutions. Is there anything I can do to these 2 guys, the square root of 12, that would make them nicer?
You can simplify them.
You can. And if you do a 4 times 3, can you trust me, you get 2 root 3, and that happens in both cases. So here are our 2 solutions. So this technique of solving quadratic equations that look this strange way doesn't involve any factoring. Would you agree? All I'm doing is adding and subtracting to both sides and taking the square roots of both sides, right? I'm doing nothing else. I'm not factoring. I'm not using the big V thing. And look, it even works for situations. You're going to have to trust me, but this one here would not factor if you tried to do it, right? If you foiled this out and tried to solve it as a factoring, it wouldn't work. You wouldn't be able to do it.
And how would we put that into WebAssign for like the answer?
It would probably be something like this, as a comma separated list.
Okay, because I would put the same exact thing in the other day and it told me it was wrong.
You'll have to tell me what question that is and we'll do it today. Is it from this list?
Yeah, it's number 8.
Okay, then I think it's time for me to do number 8. Well, this is my version of number 8. So do you have yours handy? And I'll do your version because you know they changed the numbers.
Yes. It is v squared plus 6v plus 1 equals 0. Okay,
so what I'm going to do now is I'm going to show you how we solve any quadratic equation using this technique called completing the square. So what we're going to do is we're going to combine 2 things that we've done. We're going to combine this method, right, what we did here, with solving the equations that look like that. So we're going to put both those together, and this is good. So first thing you're going to do is you're going to subtract 1 from both sides. And the reason why you want to do that is that you want this guy to be on his own, right? You want the v squares and the v's, the x squares and the x's, right? You don't want the number to be here. You want it to be over here out the road, right? Now we are going to complete the square, the whole thing, right? Now, if you want to complete the square here, you get v plus what number?
3.
Right?
3.
And then you square it and subtract. Are you happy about the minus 9, right? The square and the subtract bit.
Yes.
Things looking okay so far? So what I'm now going to do is solve one of these. Have you noticed that this guy now looks like one of these guys? So the way we're going to do it now is, as long as you do it to both sides, it's okay rule. So tell me what to do to both sides now.
Add 9.
Okay, now if you add 9 to both sides, your equation now becomes that guy. Agreed? -1 add 9 is 8. Okay, what are we going to do next? It's a kind of turning a handle. Even the only thing that really sort of changes are the numbers, not much else. So what's next?
Square root.
Square root. And v plus 3 is going to be plus or minus the square root of 8. Are we good so far? A lot of people like these questions because they are predictable, right? You do the same thing pretty much every time. The numbers change, but the process doesn't. Now, at this point, you split them into their two distinct parts, right? Right, let's look at this one. What do I do to both sides to get v?
Subtract 3.
And what do I do to both sides to get this one?
Subtract 3 too.
Yeah, as you see, it's the same kind of thing. Now, that could well be the answer. I don't know if WebAssign wants that as an answer because I know what I want to turn it into. Can't the square root of 8 be simplified a little bit? And eventually it becomes 2 root 2. And here are our two answers. And I don't think you put the v equals part in, so you'll probably have to write this guy, comma, this guy. Right, how did that work, Savannah? Have you had a chance to type it in?
It's loading.
Okay. While Savannah is doing that, it gives me a little chance to look at this entire process from start to finish. What we did there is subtract 1, right, from both sides. From both sides, FBS. And then from here to here was that new process completing the square. And then from here to here, you added 9 to both sides. And then you took the square root to both sides. And then you separate it, subtract 3, make it look pretty. How's it loading, Savannah?
It worked.
Can you tell from what you did what was different, or was it just the way you wrote it?
It was just the way I typed it in.
Okay. Now, this is a totally different way, isn't it, to solving quadratic equations. If I gave you that equation on Monday, can you see that you cannot factor v squared plus 8v plus 1, right? There isn't two numbers that multiply together that give you 1. And if you add them, you get 8. I mean, think about it. The only one you can get 1 is 1 times 1. And you see, factoring does not work. But the completing square method does. But the advantage of factoring is, see if something does factor, isn't the question really fast? And the answers are really nice. You know, if it factors x plus 1, x minus 2, it factors in 30 seconds and the answer's done in less than a minute. If you have to do completing the square, would you agree it's much more cumbersome, right? You have a lot more things to do, but completing the square will always work, right? It will get you an answer even when it doesn't factor. So let's try working backwards and do a version of question 7. And we want to solve y squared plus 4y take away 5 equals 0. And I've got this little guy beside me and I'm going to use him essentially as a template. So you'll see me doing the same kind of thing each time. What am I going to do to both sides as my next line? That's the original, but what am I going to do to both sides?
Plus 5.
Okay, in this case, add 5 to both sides. Basically, it's that line, right? That's where we are. Now, once you've done that, don't we now focus on this guy? And we complete the square. Okay, what do you get then when you complete the square then? Well, you get y plus a number, don't you? So complete the square here. What number do you get next to this y?
2 squared.
And square and subtract gets you 4. Are you happy about y plus 2 squared and then take away 4, right? Half the number of y's is 2. Square it and subtract. Right? Half the number of y's, square it and subtract. Right? Now, think of it as like a process. You do the same thing pretty much every time. What are you going to do next? To both sides. What are you going to do next to both sides?
Add 4.
Square root.
Well,
No,
that's coming
add-
right next.
ah,
Yeah,
Plus
but we're
5.
going to do the
Four.
add 4 plus, right? The add 4 first. Right. Now, you said square root. That's exactly what we're going to do now. And if you take this guy, you get plus or minus the square root of 9. And I'll separate it into its 2 pieces. That guy. And that guy. I actually shouldn't have called that 3 now to think about it, because the square root of 9 is 3, but too late now. It's 3. So you should get that. And you get that. You probably don't need this line. I just was careless. Okay, let's take this one. What will I do to both sides to find what y is? This one here on the left. What shall I do to both sides to isolate the y?
Subtract 2.
And we have got our first solution. And what we do here, we'll subtract 2. And you've got your second solution. So these two guys are the 2 solutions, there's 2 in this case, to this quadratic equation. If I plugged 1 in here, it would work. If I plugged in -5 in here, it would work, right? They would both work. You don't get a chance very often to do this, so I'm going to show you. You know this particular quadratic equation, I can factor it. So let's do Monday's technique. Give me 2 numbers that multiply together that give me -5, but when I add these 2 numbers, I get +4. It's pretty obvious that one's a plus and the other's a negative number, right? So what 2 numbers multiply together give you -5, but when you add them, you get 4. We're back to Monday. We're talking factoring here. Oh, come on. -5, 2 numbers added together.
-1 and 5.
There you go. And this guy gives you a solution y equals 1. And this guy gives you a solution y equals -5. Do you see that you get the same answer, but much quicker when you can factor? You see it's a 3-liner when you factor, and it's, well, I don't know, 6 lines or something when you complete the square. So if someone gives you a quadratic equation to solve, shouldn't you have a quick look at it and say, can I factor it? And if the answer is yes, shouldn't you probably factor it because it's going to take you a lot less time to get the answer? But if you look at it and say, nope, I cannot factor this, then won't you be able to get the answer with this backup plan, right? Using completing the square, right? You'll still get the answer. So for instance, if I gave you v squared plus 8v plus 1 equals 0, and I said, solve that one, you couldn't factor that. There's no way in the world that'll factor. So you have to do the completing the square. On the other hand, if I gave you this one, completing the square works, because completing the square works all the time, right? Doesn't matter if it can factor or not, it'll work, right? You'll get the answer. But that's a lot of work.
Sorry. Does
No,
completing the square work with like odd numbers?
It does. Do you want to see an odd number? Right. Are we cool? Do you want to see another even number before I do an odd number? What you mean by an odd number is like +3y or +5x. Agree? Yeah, that's what she means, I believe. Are we good with even? You want to see a nod now? Or do you want to see another even before we do that? I'm looking at faces, but I'm not picking up much vibe one way or the other.
I have a question. Where did the 4 come from?
The 4.
The -4 in the middle, like, so it says y plus 2
Oh, here?
squared.
This guy?
Yeah, I lost on where that came from.
Right. When we took this 4 and we halved it, we got 2. And what you do with this 2 is you square it and subtract. So 2 squared ends up being 4.
Okay, okay.
Right.
Okay.
Now, if I use this guy, which is the same kind of question, where did this 9 come from? You see, you halve this guy, you get 3. And then 3 squared, that's where the takeaway 9 came from. So you halve the number of e's, square it and subtract.
Okay, thank you.
Yeah, I think I do want to do one more even. I think it just make me feel better. And then we'll do, after that, we'll do another odd. We'll start with odd values there. So I'm back to x's, and I'm going to do negative 10x, and I'm going to do plus 7, and I'm going to do it equal to 5. Yeah. So I added just a little bit more. I put a number here instead of 0. That's all I did. But I'm keeping even x's still, right? So first thing I'm going to do is subtract 7 from both sides. We go with that. Subtract the 7 from both sides. Right? That's what we did all the other times. Now, let's complete the square here. Half the number of x's, negative 5. If you take negative 5 and you square it, right, don't you get 25? So take away 25, right? Half the number of x's, square it and subtract. Half the number of x's is negative 5, square that guy and subtract. So if you're wondering where that guy comes from, it's negative 5 squared. I'm looking for happy faces, or at least nods. Happy faces will do. Okay. Right. Don't need to write this down. I'm just rewriting that question because I've got too many arrows floating around and it's slightly distracting. Okay, what do we do to both sides now? It's the same kind of order that you do things, the same way, the same time.
Add 25 to both sides.
And if you do that, you now get 23. And pretty much standard, what's going to happen next, agreed? What do we do to both sides now?
Square root.
When you take the square root, you get a plus and a minus. And then you separate them in to 2 distinct versions. That's this guy and that guy. Okay, what do I do to both sides to solve for x, to isolate the x?
Add 5.
And add 5 again. Can we simplify the square root of 23?
No.
And so we are finished. And your answer in WebAssign would be probably this guy and that guy, separated with a comma. We feel good with even x's, right? 4x, 4y, 2x, 2y, right? That kind of thing. Feel good. So I'm now going to do the odd ones, which is really the next phase. Maybe I could find a question that does it, but if not, I can easily make one up. Perfect. Question 9. we have w squared plus 5w take away 6 equals 0. It's going to be w squared plus 5w, and you add 6 to both sides. So far, so good? Right, now, I am not going to change the rule. I'm still going to half the number of w's, square and subtract. It's just going to be a little bit more awkward, the number I get. What do you get if you half 5? What fraction do you get when you half 5?
2.5.
2.5.
2.5, but that's as a decimal. We try and avoid decimals if we can. So 2.5 as a fraction would be written in what way?
5/2.
Yeah. So we prefer you to write it like that. It is 2.5, right? And it's a little bit easier, isn't it? Because you just stick a 2 under it, right? Now, what are we meant to do with this number? Aren't we meant to square it and subtract? You know, if it was 5, I would do 5 squared. If it was 2, I'd do 2 squared. But it's 5 halves. So shouldn't I square it and subtract? Well, if you take that fraction and you square it, you mean you multiply it by itself. And if you multiply it by itself, do you see you get the rather awkward 25 quarters? Are you happy about 5 halves squared being 25 quarters, and now I've subtracted it? Right, I'm doing the same rule, it's just with awkward numbers. Are we good with that? Are you happy? Right. What should I do to both sides now?
Add 25 quarters.
At this point, we're hitting a kind of messy part, and that's kind of unavoidable, unfortunately. You don't really want to leave that as 6 plus 25 quarters. And although you might be tempted to, you don't want to call it a fraction, or you don't want to call it a decimal either. So what we're going to do is we're going to convert that by adding these together. And I'm going to do it on the calculator. So I'm going to go 6, add 25 quarters. And you see how you type it into your calculator like a calculation, essentially? And then I hit enter. Now, you see the answer as a decimal is 12.25, but we don't like decimals, really. We try and keep to fractions. Have you ever seen this trick where you can let your calculator add and subtract fractions? Right, so right now I've added them and got that. Hit the math button. Choice number 1 says fraction. Hit the enter button. And what it's going to do is it's going to take the answer and make it a fraction. So when I hit enter, like magic, 49 quarters. Is that not cool that the TI-84 can actually do fractions? You just have to remember to hit that math button, choice number 1. So I've done exactly the same steps that we did when it was things like 8 and 10, right? I've added 6 to both sides. I've halved the number of w's, squared and subtract. I've added something to both sides to get to here. So we're getting there. What should I do to both sides now?
Square root.
Okay, and when you take the square root of this side, you get that. And here you get a plus or minus the square root of 49/4. Okay, this time I'm not going to make the mistake I did last time. I'll do it on the next row, I think. Can you simplify the square root of 49/4? Can you make it nicer?
7/2.
It is, doesn't it? Split as the square root of 49, which is 7, and the square root of 4 on the bottom, which is 2. So what you've really got is that guy. And now we split it into its two pieces. You've got that guy equals -7 halves, and you've got that guy equal +7 halves. Okay, what do I do to both sides now to find W?
Subtract 5 halves.
I normally wouldn't write this down, but I am going to do it because this is messy. You know, we're going to combine these two together. Now, you might be able to do them in their head, and that's great. But let's say that the fractions are just really ugly, because sometimes they're very ugly. And I would like to do this on my calculator again, so I'm trying to get practice at that. Whenever you do negative, in this case, -7 halves, you hit this button here, negative. And then you go 7 halves. And this guy, although it looks the same and written the same, is a subtraction. And you do 5 halves. And the answer is -6. And over here, you take 7 halves and you subtract 5 halves on both sides. Only this time it's a positive guy, so just 7 halves. Subtract 5 halves, and the answer is 1. So the solution to this quadratic equation ended up being really nice answers, -6 and 1. Are we good with that? They're just uglier, aren't they, when it's odd, guys, like 3x and 5x and 7x. They're just uglier, right? I'm not changing the process, right? It's just messier things that I'm doing it with. I think I should check one of these. Let's check this one. Let's check that that actually works. Okay, so you go back to your original, which is this fella. And you put in -6. So -6 squared plus 5 lots of -6, take away 6. Right, -6 times itself is +36. 5 times -6 is -30. And then you take away a 6. Oh, perfect. Doesn't that equal 0? It works. You see 36, take away 36 is 0. I've checked it. It actually does work. Look at question 9 again. Can you factor question 9? Can you think of any two factors that would work with question 9?
Three and two, maybe?
Yeah, 3 and 2 maybe. And unfortunately, one of them has to be plus and the other's minus, so that could have worked in some circumstances. If 3 and 2 don't work, what's the only other natural combination that's left then?
6 and
Six
negative
and
1.
Right, 6 and -1 now. Which one we're going to do is 6, right? And then -1. Do you see that one works? Check it out. The two numbers multiply together give -6, and if you add 6 and -1, you get 5. Now, I don't have any room there, but wouldn't that get you the W equals 1 answer? And wouldn't this get you the W equals -6 answer? Do you see how factoring would do that question 10 times faster? But not all questions factor. That's why we needed a backup plan. So your normal strategy for solving quadratic equations is going to involve you first seeing if you can factor it. And when that doesn't work, then your backup plan is going to be completing the square. And that's why when you see the homework questions, I think they phrase them like, if you can factor it or by completing the square, right? They give you like a kind of choice thing. Are we good? Right. Let's look at another one. Let's look at one where they made life just a little touch more awkward. So this is a version of question 10. We are solving or being asked to solve this quadratic equation. It's a little bit different looking than the ones we've done today, but it's still a quadratic equation. What do you think I'm going to do to both sides to get it ready so I can do the complete and square part? Because right now it's not really ready for that. What would I do to both sides?
Subtract x squared.
Okay, subtract. Oh, subtract. No. I got what you're getting at. No. I might do that if I was trying to factor it, but I don't want to factor this one. I want to do complete in the square, so it's going to be a different approach.
Subtract 12x.
Yeah. Do you see that that's going to help me complete the square? Can you see, if I'm going to do the complete the square method, don't I need to have the x's and the x squareds together equals whatever number happens to be left over? Right, that's the basic shape I want. X squareds and x's equals a number. Now, I should be able to complete the square here. Okay. What number goes next to the brackets? Well, half of -12 is -6. Square that, you get 36. So square it and subtract, you take away 36. Are you happy about the complete and square here? Are we good? Right. Tell me what to do to both sides next.
Add 36.
Okay. Some people like completing the square because they don't need to factor, right? They're a bit rusty at factoring. That's always the thing that causes them trouble. Do you see the complete and square doesn't need factoring? You don't do factoring at all, right? So it's a totally different method. So that is kind of nice of it. Oh, this is an interesting situation. And the 36 and the -36 cancelled out and left 0. But I'm not going to let that stop me. I'm going to keep going with the process. Is it the next step to take the square root of both sides? Good. Well, if you take the square root of 0, I guess technically, don't you get plus or minus 0? Do you think you need a plus or a minus when it's 0? Did you hear about the guy who was terrified of negative numbers? He always stopped at 0 to avoid them. I should have changed that joke. He always stopped at nothing to avoid them. I just wasted that joke. It was a good one too. Okay, so essentially then, all I've got is that. And if I add 6 to both sides, we have got a quadratic equation that only has one solution. And we did get that on Monday. Well, isn't it possible that some quadratic equations only have one solution, not two? And so that's all that happened here.
Are quadratics parabolas?
Yeah.
Okay, so would that just mean it just touches like on the x?
Yeah.
Like 6, okay.
Ah, that is where this is eventually, this process will lead us eventually to sketching parabolas and quadratic curves, which are just parabolas. So yes, is the short answer. That's where this is going to lead, Vanessa. One of the reasons we might want to do it is going to lead to that. Let's phrase it that way. Right, here's a guy for you to try. Z squared equal 6z plus 1. And this is like question 11. Okay, go for it. It's not unlike this one here, except there's going to be two answers, not one. Hi guys, Bailey's in to say hi. Yes, good boy. Oh God, he's gone into sleep mode. There we go. Give you a few more things and then we'll start tackling this guy. Okay, who wants to volunteer for the first line? What shall I do to both sides?
Subtract 6z.
Well, I prefer you said 6z, but we'll
Sorry,
let that one
Z.
slide. Right. Correct. Isn't this the point where we now do what's called completing the square, right? That ugly part, right? So,
I keep getting stuck about halfway through.
okay, so maybe in the completing square part, right? Let's see what we've got. Don't you take this number and half it? Are you happy about where the -3 is coming from, right?
Yep.
Now, what do you do with that -3? You square it, right? And -3 squared is 9. So you square it and subtract. So have you noticed that you always subtract a number? You never add. So even if it's 5 or -5, when you square it, you still end up with 25 and you still subtract it. We're good with that step now. Okay, now the next step is pretty standard. What do we do next?
Add 9 to both sides.
We add 9. And if you look at all the other questions, I'm sure you'll see a line not unlike that. And now we get to maybe the awkward part. Isn't this the bit where you take square roots of both sides? So that's maybe where you're talking about you might get lost. So you take square roots of both sides and you remember to get a plus and a minus. And then you split this into 2 distinct situations. You've got z -3 and you pick the negative square root of 10, and then you've got the same z -3, but you pick the positive square root of 10. That's how you manage to get 2 answers. You split it into 2 distinct pieces. And in this case, all I need to do to find z is add 3 to both sides. And in this one, all I do is add 3 to both sides. And there is our 2 solutions. And I should check, but I know the answer. Would you agree the square root of 10 can't be simplified? You should check it in case it's 2 root 2 or something, right? But it isn't. It's finished. That's pretty standard solving an equation using completing the square. You could put 3 or 4 questions side by side that look like this, and you'd see the same kind of steps being done in the same kind of order, right? So if you can get those steps in your head, this is what I do first, this is what I do second, then this is what I do third, you'll be well on your way of being able to solve these equations using this technique. Now, I'm just having a look at our next one. We don't have too many of these to do. I think we've got about 4 left and we've kind of used up everybody by then. I have p squared plus 5p equals 1. Oh dear. Don't we have another one of these awkward odd ones? I'm not changing the process. I truly am not. I'm just going to have to deal with ugly numbers that I'm doing it to. Half the number of p's, 5/2. Square and subtract. If you take 5 halves and multiply it by itself, you get 25 quarters. So half the number of p's, 5 halves. Square 5 halves and subtract, 25 quarters. It's exactly the same as this one. It's just it's ugly numbers, fractions. It's still half the number of p's, square and subtract. Okay. What should I do next to both sides?
Add 25/4.
At this point, can't we use calculator? Right. So I'm going to do that little trick that we've done before. I'm going to let the calculator combine these two, add them. I'm getting 1 plus 25 divided by 4. That's 25 quarters. I'm hitting enter. I'm pressing the math button, choice number 1, which turns my answer into the fraction 29 quarters. So I guess that's an extra line only because we had awkward things. Same, next step is the same every case. What is our next step?
Square root it,
Yeah,
both sides.
agreed. Square root it. And while I'm at it then, can you simplify a little bit, even if it's only a little bit, 29 quarters? I know I can't do too much, but I can do a little. If you look again, is there anything that I can do to make it just a little bit less square rootish?
I want to say 29/2, but I don't think that's right.
Well, you should be right because you were right. Stop talking yourself out of the right answer. It is. You know that a square root of a fraction, you can deal with the top and bottom separately, and the square root of 4 gets you 2, and that's why Rachel said 2. And it's all plus and minus, right? So that's now going to separate as this fella, and the other one is this fella. And then I'm just going to subtract 5 halves from both sides and get that ugly answer. And then I'm going to subtract 5 halves and get that ugly answer. And I'm not going to make any attempt to combine them because you can't. The answer is just ugly and there's no way to avoid it being ugly. Are we good? As I say, we only have a few left. This one here is similar to question 12. This one is similar to 13. It's another odd one. Okay, what number goes next to the R plus? Or I should say, what fraction goes next to the R plus? No takers yet. What happens to that 7? What does it turn into? Come on, don't be shy. I know you know the answer. What do we get?
7 halves.
You do. Now, if you square 7 halves, right, if you multiply it by itself and subtract, you get 49 quarters. Okay. Now, you can then add 49 quarters to both sides. And I'm going to let the calculator take care of this guy. So it's 6 plus 49 quarters. You get that guy. Hit the math button, choice number 1, and enter, and you now have 73 quarters. Okay. Where do we go next?
Square root.
We do it. Yeah. And that's going to give me plus or minus the square root of 73 quarters. Let's look at style points. Is there a nicer, even if it's just a little bit nicer, version
Number
of
4
this?
to the 2.
Yeah. Kind of like what Rachel done the first one, right? Same idea. Right, now what you're going to do is you're going to split it into 2 pieces. So that guy is going to be negative the square root of 73 over 2. And this one here is going to be just positive square root of 73 over 2. And oops, I forgot. I'll try recover. There we go. And then you subtract 7 halves from both sides to get the answer. And you subtract 7 halves from both sides to get the answer. And those 2 ugly answers are the result. So we have a technique here called completing the square that allows us to solve quadratic equations that don't factor. It's quite a long question, a technique. It's quite a long technique. You have to do lots of steps. But if you do enough of them, you start realizing it's just the same steps repeating themselves each time. Then we have essentially 2 examples for you to try. And we will be finished completing the square. No, sorry, rewrite that. It's going to be the first one, 14. And the last one is going to be 15. Okay, guys, give you 5 minutes. Go for it. Try and get both done, but at least hopefully get one done. Solve that one. Rachel, you can do one of them, and your son can do the other. Okay. Hi, Sarah, too. You finished these two guys? Well done. That was very fast. Okay, let's get this show on the road. So hopefully you've got one done and you can kind of follow through with the second. Right. In this one, I'm basically just going to half the number of y's, square and subtract. Then I'm going to add 25 to both sides. And then I'm going to take the square root of both sides, and the square root of 16 gets me 4. So I end up with -4 and +4. And if you subtract 5 from both sides, you get -9. And if you subtract 5 from both sides, you get -1. So hopefully you got -9 and -1 on the first one. Okay, next one then. What do I need to do to both sides to get this ready? Because it's really not written in the form that's going to let complete the square work here.
Add 1.
Okay, agreed. Add 1. Okay, now, nice round number, so we don't need to worry about weird fractions. Half the number of y's, square and subtract. You happy about that? Half the number of y's is -3, square, you get 9. What should I do to both sides next?
Add 9.
Is it beginning to, although it might be boring, is it beginning to have a process that you cannot follow? The numbers change, but the process doesn't. What should I do next to both sides?
Square root.
Just, can the square root of 10 be simplified? No, so we'll leave it. So what do we have? We have this guy negative the square root of 10, and this guy equals positive the square root of 10. If you add 3 to both sides, you get that answer. And if you add 3 to both sides, you get the second answer. So here are our two guys. Okay, we need a break, including me. So I'll see you back here at 7. Or you can hang about and I'll bug you and ask you things if you're not careful. Alyssa, where's your dog that you frightened? Is it still around?
Yeah, she's still over here.
Is she old?
Yeah. We don't exactly know how old she is because we got her from the pound.
Okay.
But we think she's around 12 or 13.
Oh, it's getting old. Look, I didn't catch much, but it looks like it's a labby, some kind of something, is it?
Me too.
I should sit tight. I almost seen its back. I made a bad assumption. So it's quite a little dog.
Yeah, she still acts like a puppy.
Yeah, my sister has a Shih Tzu. I've seen your Shih Tzu now that I remember. My sister's dog has eye problems. You know, a lot of pure breeds have, different breeds have different problems.
Yeah.
She has, yeah. So, yeah, she has eye problems. I don't know if your dog has the same issue.
She has one little eye problem, but it's like not that big of a problem, I guess.
Yeah, well, my sister's dog is getting on in the years, and I think as they get older, things happen. I'm trying to remember. I've got a Westie, and Westies are notorious, at least the ones we've had, to have skin allergies. That's kind of a weakness in the breed. I'm trying to remember what you call them. German sheepdogs, American call them Alsatians. I know people have Alsatians, and they seem to have their back legs go. They have arthritic issues in their back legs. That seems to be a weakness in that breed. So, the healthiest dogs are actually the mongrels. So if you get a good mongrel, they tend to be very. They don't have many problems. A lot of them, at least. What you got, Carla? You got kids, I know, but you got dogs in there as well, or not?
Cats,
That's in plural, so there's 2 of them.
plural.
Inside ones or outside ones?
Inside, but they're getting close to getting tossed out the door. So
Uh-oh. Are they scratching the place up?
no, just one just likes to try to sit on me, and she gets mad if I don't hold her while I'm studying.
Yeah, Bailey came in. Oh, look at that thing. Oh, it looks like it's just hanging there. Yeah. That's a nice one. Yeah. Yeah, we're very much pet people or dog people. In our case, you're cat people. But you might be dog person as well. You might have had dogs in the past.
I would take both, but I live in an apartment, so it's
Easier and smaller, and they don't need walks and poo walks. Yeah, we get round the poo walk problem with Bailey, our dog, because we have a doggy door on our deck. So he goes through the doggy door, and then we have a wraparound deck. So he basically goes out and does his business, and I'm glad of that because he does it. I've seen him. He's waking me up sometimes, and 3 o'clock in the morning, and he has to go out. So I'm glad I don't have to waking up and do it. When you got the doggy door, that was kind of cured. So, but if you live in an apartment, I don't think that's really practical.
no. No.
So who else? Jamie Lynn, you haven't got a pet, but you'd like one, right? Hi, Jamie Lynn. Don't know if you can hear me talking to you. No, she's probably listening.
Oh, no, I was trying to unmute.
Oh, okay. So
Hi.
you don't have a pet, but you would like one?
Me?
Yes.
I have a hamster cage right next to
Oh,
me.
that does.
but-
Well, I guess it does count.
And
as a
then
pet.
we do have a dog in my house. So I do have pets.
You do have a pet, okay.
Yeah.
But you say it like you're not living in your house, like you're somewhere else, and back home in your house you have a dog.
Oh, no, it's not my dog. It's my dad's fiance's dog.
Okay.
So technically it's a pet of the house. That's not my pet. But I can say my hamster's my pet.
Hamsters work. Hamsters, I had a hamster when I was really young. And not my own, I kept it for the school. They do things, probably do it in American schools. But when you're very young, they have like the class pets, right? Which in our case were hamsters. But during the summer breaks and the long breaks, one of you got the responsibility of taking the whole stuff home and looking after it.
I
So
wish I can show
I
my
got a hamster.
I wish I can show them, but like rodents are harder to tame. So then I just kind of like, we have a mutual relationship kind of. But
well, as long as you feed her or him, he won't bite you.
yeah, it doesn't bite me. Like it nibbles on me. Like I just kind of like jump because it's like, oh. And then I feed it like treats on my hand, like holding it like this, and they'll like take it from my hand. So like it's a mutual love-hate relationship.
Oh.
Yeah.
What about you, Sarah, too? You're Sarah too, I think. Are you?
No,
Yeah.
I
You
don't have any pets.
Do you want a pet?
I think so, yeah.
Is it just life right now doesn't really make it feasible?
I always say when I grow up, aka move out, I want a pet. I like both cats and dogs.
So if you had dogs and cats in your family house over the past time, in the past?
We had a dog when I was like a baby, and I had guinea pigs for a while.
We didn't have pets in our house because of the size of our family. So when I got the hamster to take home, I was quite pleased because for a whole summer I had a pet. But Jamie Lynn's not meant to listen to this, but they don't last very long. They only have a short lifespan.
Yeah, that's what one of my friend tells me, and then I just yell at them.
Yeah, you shouldn't have listened to that.
But
yeah, there was a girl in my school that once told me that. She's like, I just got them too. And she's like, I think she's like, if you don't get them spaded or neutered, they're gonna die a lot sooner. I may or may not have politely told her off and made her cry.
But I think it also depends on like the environment, because the cage I put in my hamster is a glass aquarium cage instead, and then I kind of put more the natural look of it. I don't know. I don't think that makes a difference, but
Well, whatever time they have, at least they have a good time.
yeah, I
'Cause
wanted.
out in the wild, things are always trying to eat them. So out in the
Yeah.
wild, those creatures they probably live a very terrified life, a short and terrified life.
They're really skittish, but I wanted a snow dwarf hamster, but the pet shops don't really get snow dwarfs, so I was like, I'll just get the dwarf hamster. Similar, just the snow dwarf hamster is like white, and the robo is like white and brown.
I had a robo. Its name was Squanchy.
My hamster's name is Tubbs.
Oh,
Yeah, and he's
How
kind
old
of
Is that because he's slightly fat?
yeah, he's fat now. He's a little fat now, but I don't know how old he is. He's like got him this year, the beginning of this year. So like I don't know when he was born because pet shops. But
They get taken away from their mum pretty quickly.
yeah,
They're
I'm
probably
pretty
quite young.
sure it's like not a year old yet.
And Vanessa, you had one that was called what again?
Squanchy.
That sounds like a sci-fi character from The Mandalorian.
It's actually a character from Rick and Morty.
Don't know that show's an American cartoon show.
Yeah, it's like a newer show, yeah.
Okay, well,
I was thinking about that. I know.
Let's get let's get started on our next topic. Before I forget, because I know I will, because I'm getting old and I forget all sorts of things. You know, Monday's a holiday, so don't turn up because we won't be here. Just to remind you. What else do I need to remind you of? I think, unless I'm mistaken, is this Sunday when homework is due? Okay. Since Monday is a day off, I will just move the homework till Tuesday midnight because it gives you a few more days, right? So you've got until Tuesday midnight. I'll have to wait until this lesson is finished and then I'll go and do it. But if I write it down, I probably won't forget. And if for some reason I forget, you shoot me an email so I can unforget and do it. So I'll do it on Tuesday midnight is going to be your new time schedule for that one. So
I haven't had a chance to look yet, but is extra credit up?
no, but that is another thing that I have forgotten. I told you I forget things. So why don't I put the extra credit up at the same time? So sometime towards the end of this evening, because it'll take me a little bit of time to put it together, there's going to be in Canvas a thing called extra credit, 2% extra credit. And you're going to go into it and you'll see what it is. And I won't say any more than that, but basically what it's going to be is I'm going to ask you to do some questions and you write down the answers. And you're going to be able to see a PDF with the questions on it. And then all you do is tell me what the answers are. You don't tell me the working because it would take too much time to check all the working, but you'll tell me the answer. And the questions that you're going to be asked to do are going to be factoring and solving quadratic equations. So that's what your extra credit is going to be. Factor these guys and solve these quadratic equations. So,
Was there not extra credit already in WebAssign?
did I?
Yeah,
Oh, well, I am good. Then I thought I'd already.
But it was due the 23rd. That's what it said on Canvas. Or
okay.
Yeah, it was
Since I
the factoring extra credit.
Oh, so I have done it. Okay. So does that mean some of you missed it? Told you I have a bad memory. Right. Well, what I can do instead is I'll just go into WebAssign and I'll move the time to do the extra credit to the same Tuesday as everything else. So it'll all be done in the same time span. So if you haven't done the extra credit, you can certainly go back there and do it. And if you have, then it's done. But I was going to do a PDF of it, but now I don't need to because evidently I did and just forgot. But let's get started on our next topic. And we are going to be using a thing called the quadratic formula. And the quadratic formula is another method for solving quadratic equations. And as it names suggests, it's actually a plug and jug formula. But before we look at what this formula is and how you do it, we need a kind of intro. We need to get used to some things. So the first thing I'm going to tell you or show you is that guy. And this is called the standard form of a quadratic equation. Right, so the standard form for a quadratic equation. All quadratic equations, if you want to use this formula, have to be written like this. So many x squareds plus so many x's plus a number equals 0. For example, 3x squared plus 2x plus 7 equals 0. Negative 3x squared minus x plus 2 equals 0. 1/2 x squared plus 3x minus 1 equals 0. These are all examples of quadratic equations written in their standard form. So you might think, well, if I've got factoring as a technique, and I've now got this new guy that we've learned today called completing the square, why on earth do I need yet one more technique called quadratic formula? And the reason for it is a lot of quadratics don't factor, but they also don't lend themselves to doing completing the square. Would you agree that you can't do completing the square on this question? And the reason you can't do it is, isn't there a 3x squared here and you need an x squared? And although that may not seem like a big deal, it really is a big deal. It causes all sorts of problems if you try and solve it by adjusting it. So we need this third guy. Now, for each one of these quadratic standard form equations, we need to know who A is. It's 3. Who B is, it's 2. And who C is, it's 7. In this question, A is 1/2, B is 3, and C is -1. And I guess I'll change my color scheme. In this quadratic equation, what number is A? In this middle one, what value is A?
-3.
Great. And what value is B? What number is B?
-1.
And finally, I'll do C, it's 2. If an equation, if a quadratic equation is written in its standard form, and do you feel comfortable that you should be able to tell me who A, B, and C are, right? Because A, B, and C are going to be the guys that make up the quadratic formula. The quadratic formula is going to have A, B, and C's in it. So let me show you the ridiculously ugly formula called the quadratic formula. Now it would be really good if you could memorize this, but you're probably going to write it down on a piece of paper when you do the section where we solve using the quadratic formula. Now, as formula goes, would you agree it's a pretty ugly looking formula? It's got square roots in it. It's got things being squared and multiplied and subtracted. It even has a plus and minus thing going on, right? But nonetheless, this guy can solve every possible quadratic equation in the universe. If it's doable, this formula will solve it for you. So it doesn't matter if you can't factor it. It doesn't matter if you can't use completing the square. But you should always make this your last choice. You shouldn't try this technique unless every other technique has failed, because it is very difficult to get the answer to this formula correctly, right? We tend to screw up because there's so many little bits to the formula that, you know, you lose a sign here or you forget to square something or so on. So I'm going to show you how I would tackle this based on the fact that I screw up a lot. Let's suppose I want to solve 3x squared plus 5x, take away 12 equals 0. And I've tried to do the big cross, right, the magic cross, and it doesn't factor. And I know that I'm not going to be able to do completing the square because it starts with a 3x squared, and I know completing the square really doesn't work with that. So I'm stuck with the last alternate. I'm going to do the quadratic formula. So step one. Make sure your quadratic formula, your quadratic equation, I should say, is in its standard form. Right, so before you begin, make sure your quadratic equation is in its standard form. Is this guy written as so many x squareds plus so many x's plus a number equals 0? Yes, that means it's good to go. Why is that important? Well, sometimes you'll get a quadratic equation and they'll look like this. Right, that's a quadratic equation. It's got an x squared in it and it's an equation, so it's a quadratic equation, but it is not in its standard form. What you would need to do here is subtract 3x from both sides and subtract 7 from both sides. Do you see that it's now in its standard form? So step one, make sure your quadratic equation is in its standard form, right? Since this is notes, I'll write this down. I typically wouldn't, but I will for this one. Right. Make sure it looks like that. That's step one. Taking this really slowly. Step two. Find the values of A, B, and C. Okay. A equals, B equals, C equals. Okay. For this quadratic equation then, what is the value of A? What number is it?
Three.
Agreed. What is the value of B?
5.
And finally, what is the value of C?
-12.
Right. Would you agree that that step's not too difficult if you do step one correctly? Right. A is the coefficient of x squared. That just means the number next to the x squared. B is the coefficient of x. That's the number next to the x's. And C is called the constant term, and that's just a number that doesn't have any x's. So that's A, B, and C. Now you might think step 3 is plug and chug. I would never do a plug and chug with that formula because there are so many things going on. I would probably screw up somewhere, right? Half the time anyway. I get a sign wrong, I do something wrong. So I break this question into pieces that are manageable. So step 3 is find the value of this guy. Just this piece of the formula, right? The guy inside the square root. Just find that guy. Nothing else. Just that guy. Now, I'm not the only person who does that. Do you know they even have a name for it? They call that little piece the discriminant. Right, b squared, 5 squared. Take away 4 times 3 times negative 12. Right, I could do that on my calculator, probably. Well, not probably, I can do this on my calculator, and I won't screw up. So here goes. 5 squared, subtract 4 times 3 times bracket negative 12. Oops. There we go. Now you look really carefully. Do you notice I've put a bracket and a negative 12 around that guy? I hit this button here. So when I hit answer, it ends up being 169. Let me show you how you can do this and you screw up. You go 5 squared. Take away 4 times 3 times bracket, subtract symbol 12. If you look really closely, isn't the negative sign a little smaller than the subtraction sign? Now, what happens when I hit enter? You see it says error, quit, all that nonsense. Make sure that if any of the numbers are negative, that you kind of put a bracket around it and use that guy. That's the safest way to do it. So I would go, just to repeat the calculation, 5 squared, subtract 4 times 3 times brackets, negative 12. So if you ever see error, right, syntax error, the chances are that you've used a subtraction sign when you should have used a negative sign. Subtraction is a process, negative is a value, right? Negative 12 is part of the value. Well, that's step 3. Find b squared, take away 4ac. Now step 4. X is equal to negative b plus this guy. And x equals negative b. Take away this guy. And I'm now going to use the quadratic formula. So here goes. Negative b. B is 5. So that's negative 5 plus the square root of 169 divided by 2. And this guy here, the other solution, well, it's going to be x equals negative b, negative 5, take away the square root of 169, all over 2. Square root of 169. Can that simplify?
Wait, is it not over 2a?
Oh, 2a. Darn it in space. Well done. 2 times 3. Okay. Is square root of 169, can that simplify? It can. What number is it? Because it's actually a perfect square.
13.
Okay, so what do I get? I get negative 5 plus 13 over 6. And I get negative 5, take away 13 over 6. Negative 5 add 13. I get 8. Negative 5 take away 13. I get negative 8. Negative 18, I should say. This becomes 4/3. And this becomes negative 3. So step 4 is basically the last step. But for me, I find it easier to do the b squared minus 4ac first and then work our way through each of the steps to get there. Would you agree this is a very, very long process, even longer than completing the square? And I already screwed up by doing 2 and not 2a. So you got to be really careful when you do it, that you don't do similar kind of mistake. Okay, let's show you another one. In fact, you lot are going to create a quadratic equation for me. So this is kind of going to prove that every quadratic in the world can be solved. So Sean, give me a number, positive or negative, between 1 and 5.
Let's go with 4.
Okay, so it's going to be 4x squared. Give me a number between plus or minus 5. Sarah, 2.
3.
Does nobody like negative numbers?
-3.
Nah, too late now. I'm picking it negative 10, right? There. So, isn't this one okay? Isn't it already in its standard form? So I don't need to do step 1. So A is 4, B is 3, and C is negative 10. That's basically step 2. Write down what the guy is, right? That's step 1. Step 3 is find the value of this guy. So that's 3 squared, take away 4 times 4 times negative 10. Oh, come on. Wow. I did not make that happen. It's just sheer coincidence. 169. I mean, check it in your calculator. I should check it as well because it is late in the night and I might have screwed up, but I don't think I have. It's 3 squared. Subtract 4 times brackets negative 10. Yeah, 169. So step 4 is the quadratic formula now. So negative of 3 is negative 3, plus or minus the square root of 169, all over 2 times 4. I'll take this as one last step. Isn't the square root of 169 a nice number? It's 13. That's what surprised me. And 2 times 4 is 8. Right, I should be able to get 2 answers here. Negative 3 take away 13 divided by 8. And negative 3 add 13 divided by 8. And this guy gets you negative 16 over 8, which is negative 2. And this guy gets you 10 over 8, which simplifies down to 5/4. It's a little bit quicker when you kind of take out some of the writing and the steps being written down. But can you see the basic format? Find ABC, find the value of b squared minus 4ac, plug that into the quadratic formula. When it looks like that, to me, that's just more manageable, right? If I didn't do it that way, I'll just show you, or I'll try to show you over here what it would look like. Negative 3 plus or minus the square root of 3 squared, take away 4 times negative 10, all over 2 times 4. If you try to do that calculation in one go, and I know that's a bit crushed, but that says 4 times 4. Can you imagine there's a great chance you'll probably screw up? There's just too many balls in the air, right? Too many things to keep track of.
Yeah, that's how I learned it.
What, to do this bit here? Or
No,
just,
to put it all in one equation.
oh God, you poor soul, Sarah.
But I feel like I kind of just like did the same thing, but I just grouped it. So I left like the -3 alone. I did what's inside the square root. And so I basically just skipped having to write the whole equation out now.
Right. Right. So is this working for you? Is this kind of what you did, but even if it isn't the same exactly?
Mhm.
Right. So that's good. The idea of getting you lot to create an equation kind of failed miserably, not because we didn't get one that worked, but we got one that was too easy. I was hoping to get a really ugly answer. So why don't we do one last one, which I will make up, because that way I'll guarantee to make it ugly, because Sean and Sarah are absolutely useless at picking numbers. And I'm going to pick some really ugly numbers just to show you what a really ugly answer looks like as well. So it's going to be -2x squared plus 5x minus 4 equals 0. And if this ends up being 169, I'm just going to go home and give up, right? Because there's no way that should be a nice answer, right? I don't think anyway. So A is going to be -2, B is going to be 5, and C is going to be -4. I'm doing the B squared, take away 4AC part now. It's going to be 5 squared, take away 4. Ooh. Going to make that 15. So it's take away 4 times A times C. So that's going to be 225, take away 32. Yeah, that's much uglier. And it's positive. And I get 193. Can we just assume that 193 can't be simplified? I don't think anything's going to be good. So that's cool, because I wanted a really ugly number. So the solution is -b plus or minus the square root of the discriminant all over 2a. So it's going to be the negative of this guy, which I've now chosen to make it 15, plus or minus this guy, all over 2 times -2, which is -4. And so I'm going to have x equals -15, take away the square root of 193 over -4. And I'm going to have -15, add the square root of 193 over -4. There, would you agree that that answer is distinctly ugly? Can we make it prettier? And the answer is we should try. So what I'm going to do with these guys is, first thing I'm going to try and do is the square root of 193. And that's failing miserably. So I'm going to just give that one up and say it doesn't simplify. But I can do this now. And what that gets me is 15 quarters plus the square root of 193 over 4. And this one that gets me 15 quarters take away that guy.